Welcome, academic chemistry students. What we're going to do with this podcast is review the lesson from last week that you guys missed. And so we're going to be talking about chemical equations, and this is part of the series of putting the puzzle together in chemistry. Before I move on to Unit 5, I want to recap Unit 4. And so we started out Unit 4 talking about how it is that atoms bind together. And so bonding is happening at the valence electron level. So we look at the valence electrons, we look to see how many valence electrons there are, and we can determine how atoms are going to either share those electrons or hand them off to other atoms. And so we learned about ionic bonding, and we learned about covalent bonding. And then we learned the structure of a chemical formula and how to name chemical compounds. With chemical formulas, we learned about that the symbols represent the elements and that the numbers can either be coefficients or subscripts and what those things mean. And then we put that all together to determine how many atoms, elements, and molecules make up a particular compound. And so now we're at the point where we're going to learn about chemical equations. And chemical equations are kind of like a recipe. And so I've got a recipe here for a batch of cookies. And so this recipe yields 24 cookies. You need to use 3 eggs in your recipe, 2 cups of flour, 1 cup of sugar, and that gives you 24 cookies. I would highly suggest that you not try this recipe because there are some really important things missing, like butter and chocolate chips. So don't try this at home. But if you look at this recipe, you see that there is a very specific ratio of the number of ingredients that you have to put in and the yield of how many cookies that you get. And so if we look at this recipe, and if we wanted to double the recipe, if we wanted to get 48 cookies because we're having maybe a party and we need extra cookies, we would double the recipe. So we would add 6 eggs, 4 cups of flour, 2 cups of sugar, and that gives us 48 cookies. And so this is really similar to the way that chemical reactions work. But the thing that we have to understand about chemistry is that there is a law, there's a physical law called the law of conservation of mass. And what this tells us is that mass cannot be created or destroyed. So what goes into a recipe needs to come out, or what goes into a chemical reaction, which is, we look at chemical reactions in the form of a chemical equation. What goes in has to be accounted for on the other side. And so we put in 3 eggs, 2 cups of flour, and 1 cup of sugar into our recipe. We get out 24 cookies. The mass of every ingredient has to equal the mass of what you get out of the whole baking experience. And so if you were to weigh the eggs, the flour, and the sugar, how much that weighs should equal the weight of the cookies. But in reality, that's not the case. And one of the reasons is that when you bake something, very often you lose water. And so it's kind of important to understand and take into account everything that is happening in a chemical reaction so that when we write out a chemical equation, that we account for everything, all of the matter that's involved, which means all of the mass that is involved. Another way of looking at our recipe is that we could abbreviate the names of our ingredients and the product of the cookies. And so 3E plus 2F plus S yields 24C. And when we do this, it starts to look a bit more like a chemical equation. Okay, and so keep this in mind. So before we move further on chemical equations, I want to remind you of the different parts of a chemical formula. And so we start out looking at the symbols, and the symbols will tell us what elements we're dealing with. So you tell me what element Na is. I'll give you a moment. And hopefully you got that right. So Na is sodium. S, you may not know, and I'll let you know that it is sulfur. And O, I'm sure you know. You know that that is oxygen. Okay, so these are the different elements. Now, the question is, how many different elements do we have? Well, we have 3 symbols, so that means we have 3 elements. Now remember that these small numbers that are to the right of some of the symbols are called subscripts. And the subscript tells you how many atoms of each element you have. If there's no subscript, we need to assume that there's 1. So no subscript means 1. And so how many oxygens are there? That's right, you've got 4 oxygens. How many sulfurs are there? We've got 1 sulfur. And how many sodiums? We've got 2 sodiums. So according to the subscripts, the ratio of sodium to sulfur to oxygen is 2 to 1 to 4. And then this final number here is called the coefficient. What the coefficient tells us is how many of the entire compound or molecule we have. Okay, so what the coefficient is telling us is that we have 2 sodium sulfates. 2 sodium sulfate. Now, I don't expect you to know how to name that compound. Okay, so now let's look at a chemical equation that we've seen before, so you should be pretty familiar with it. We want to identify some of the different parts of a chemical equation. So on the left-hand side of the arrow, we have the ingredients in our recipe, and these ingredients are called reactants. On the right-hand side of the arrow, we have what would be analogous to the cookies. This is called a product. So make sure you know what that means or what those terms mean. Now we want to ask ourselves, when we look at an equation, is everything balanced? What that means is, does the equation obey the law of the conservation of mass? Remember, what goes in has to come out. There has to be a balance between the left and the right sides. So the way that we do this, I'm going to give you a really systematic approach to doing this. Okay? We are allowed to change the coefficients. Okay? But we're not allowed to change the subscripts. No, cannot change these. So make sure that when you balance equations that you only change coefficients. And so I like to use a table that looks like this. And so in this table, what we're looking at is, what are the elements that are on the reactant side and on the product side? So remember, reactants are on the left, products are on the right. So when we fill this in, we're going to put the name of the element here, or you could put the symbol, doesn't matter. So we put H and we put O, and then we count on the reactant side how many we have. So we look at the subscript will tell us how many H's we have. So we've got 2, and the coefficient also tells us. So we have to take both into consideration. Since there's no coefficient, we have to assume that the coefficient is 1. And so we simply have 2 hydrogens, because 2 times 1 is 2. So we're going to take away that coefficient, because we don't want to keep that like that. So how many oxygens are on the reactant side? You figure it out. All right, we've got 2. Now we want to go to the product side, and we want to do the same thing. We want to count how many hydrogens. Well, looks like there's 2 because the subscript tells us 2. And oxygen, no subscript, means there's 1. So essentially what we've done here is we have determined the original state of the equation before we balance it. So I like to call this before. And I like to add a couple more columns to the table. And you're going to find on the next slide that I've already done that for you. So let's just move to that slide. I'll actually move a few slides here because what I've got for you is the step-by-step instructions, and I don't need to read through that because we're actually doing that. Okay, so we're at this slide here where it says that we need to keep track of all the changes that we make to the numbers of the elements. All right, here we go. So on the reactant side, well, first of all, let's put the elements in again. Hydrogen and oxygen. On the reactant side, we said there's 2 hydrogen and 2 oxygen. And on the product side, we said there's 2 hydrogen and 1 oxygen. So now we're going to start to try to change things around a little bit to make these numbers even, because as you can see, oxygen is off from the left to the right, or the reactant to the product. So there's 2 oxygens on the left and only 1 on the right. We need another oxygen on the right. So take a couple of moments here to try to figure out how you can increase the number of oxygens on the right by only changing coefficients. You're not allowed to add any subscripts. So remember, the subscript for oxygen is 1. You cannot change that. We can put that in to see that visually. So try to figure out what we do here. I'll give you a couple of seconds. All right, so hopefully you figured out that if you put a 2 here as your coefficient, that'll give you 2 oxygens. And so once you make a change anywhere, whether it's on the reactant side or the product side, you have to keep track. So what we do is we fill in the reactant side and the product side after we've made changes. So let's just copy over what the numbers were before, and then we look to where we've made the change and we change the numbers. So now we have 2 oxygens, but now we also have 4 hydrogens. So we've balanced here, but we're not balanced here. So what we're allowed to do now is go to the reactant side, which would be this right here, to try to get this to equal 4. So let's come over here to the reactant side for hydrogen and try to figure out what we could do to make it 4 hydrogen instead of 2. Hopefully you figured out that you could put a 2 there. And what that does for us is it changes that 2 to a 4, and now we have 4 hydrogen on the reactant side, 4 hydrogen on the product side, 2 oxygen on reactant, 2 oxygen on products, and this equation is now balanced. Before we move on, I just want to explain to you what this chemical equation is showing you. This chemical equation is showing that we take 2 quantities of hydrogen gas to 1 quantity of oxygen gas, and that gives us 2 quantities of water. And the name of water is actually dihydrogen oxide. All right, now we can go to the next slide. Here's a new equation that I'd like you to try to work through. So take a little time. I'll give you a little time to work on this. As a matter of fact, you can just pause the video, take as much time as you need, and then come back when you're ready to see me help you out with this. Okay, so give it your best shot. All right, welcome back. So on the left-hand side, we've got nitrogen and hydrogen, and we've got 2 nitrogens and 2 hydrogens on the left, or on the reactant side. On the product side, we have 1 nitrogen and 3 hydrogens. Okay, so what I'm going to do is I'm going to carry that over to our after, and now start making changes and crossing things out. Alright, so we have 2 nitrogens on the left, or the reactant side, and only 1 on the product side. So it makes sense that if we go over to the product side, which is right here, we have only 1 nitrogen. The way that we can get to is we can put the coefficient 2. And now that we've done that, what we need to do is we need to make changes here on the product side. So where we had 1 nitrogen before, we now have 2. But we also changed the hydrogens. So where we had 3, we now have 6. Okay, so the nitrogens are balanced, but our hydrogens are not. So let's see what we can do. We can go over to the reactant side and look at hydrogens. Is there a way to make those 2 hydrogens equal 6? Sure, there's a way. We can just use 3 as our coefficient, and now we have 6 and 6, and this is now a fully balanced equation. Alright, we've got 2 more equations to balance here. And what I'm going to do is I'm going to give you, we're going to hold off on these. There's a worksheet that we're going to work on in just a little bit. But I want to do a recap of this lesson, and then we'll move over to the worksheet. Okay? Alrighty, so to recap, a chemical equation is a chemical reaction showing us reactants and products, very like a recipe. Now, the law of conservation of mass tells us that mass can't be created or destroyed. So that means that what goes into a chemical reaction has to come out as far as mass is concerned. And when you think of mass, think of matter, okay? And when you think of matter, think of the numbers. And so the numbers have to balance. And the last point that I'd like to make is that in balancing chemical equations, we can change coefficients so that the number of elements is equal on both sides. But remember, we cannot change subscripts. Okay? So join me in working on the chemical equation worksheet. I'm going to bring that up for you, and you go ahead and bring that up as well. Alright guys, welcome back. So here's the worksheet that we worked on in class. And you'll notice that the first 2 chemical equations are the ones that we just did. And so I'm not going to go through these with you because we just did that, but I do want to go through the next 2. Now your quiz is going to be an equation that you need to balance, and it's not going to be one of these. It's going to be an equation that is close to the same difficulty as these, so it's not going to be terribly difficult, and you'll be able to use your notes, you'll be able to use this worksheet to figure out how you would balance that equation. So let's go right ahead now and balance this first equation right here. First equation we're going to be working on. So what we have is something called methane, which is natural gas, and in the presence of oxygen, if we put a little bit of energy in by lighting the methane up and allowing it to burn, we end up with carbon dioxide and water. So this is a real equation of a chemical reaction, and we want to balance it. So of all 4 of the chemical equations that I give you, this is probably the more complex of the 4, the most, okay? So keep this in mind. So let's first of all write down all the symbols for the elements. So on the reactant side, we see that we have a carbon, we have a hydrogen, and we have an oxygen. And we should have the same elements on the product side. So go ahead and check that out. I see a carbon, I see an oxygen, and I see a hydrogen. But then I see oxygen again. Now that's not a new element. That just tells us that oxygen now is part of 2 different chemical formulas. So don't be fooled by that. You haven't added an element. Okay, So let's count up the numbers now. On the reactant side, I see we have 1 carbon because we do not have a coefficient written, so we have to assume that that's 1, and the subscript is 1. And so always keep that in mind, okay? Don't let that confuse you. I'm going to get rid of those numbers. Alrighty, so I'm going to write down that we have 1 carbon, we have 4 hydrogens, and we have 2 oxygens. Alright. Now we go to the product side and we count them up. I see 1 carbon. I see 2 oxygens here, but I also see an oxygen right there. And let's not get fooled by this, okay? There is only 1 single oxygen because there is no subscript and there is no coefficient, so there's only 1 single oxygen. So let's say that there's 3 oxygens. Oh, I skipped hydrogen. And 2 hydrogens. Okay, so I'm double checking my numbers here. 1 carbon, 2, 3 oxygen. Okay, good. So this is not a balanced equation. If it was, the numbers would be equal on the reactant and product side. So let's rewrite these numbers. 1, 4, and 2. 1, 2, and 3. And now we're going to make some changes here. I'm going to get rid of these arrows so I don't get confused. Okay, so we see that both hydrogen and oxygen are off as far as numbers. Is there a compound on the product side that contains both hydrogen and oxygen? Yeah, there is. This is how I would approach this. I would go to that molecule right there, which is water, and I would try to even out the numbers of the oxygen and hydrogen. So let's try that. Okay, so if I say that there's 2 waters, let's see what that does. So that means that I will end up with 4 hydrogen and 2 oxygen. And does that make our numbers even? No, I made a mistake here. Hold on a second. That's not, you can't go from 3 oxygens to 2. No, that's wrong. So we started with 3. We have 2 here. Ah, okay. So oxygen, there's 2 oxygens there, and there's 2 oxygens there. So that means I went from 3 to 4 oxygens. Oh. Okay. Well, we're closer to being balanced, but oxygens are still not balanced. So where am I off here? Well, I'm off right here with the oxygens on the reactant side. So let's go to the reactant side and let's see what we can do on the reactant side. Oh, okay. So I've got 2 oxygens there. If I put a 2 here, then I end up with 4, and I can change this, and now we are fully balanced. Ah, that's great. Whew, I was worried there for a bit. But that was a 2-stepper. All right, let's look at this final equation, and let's try to balance this one. So what we have here, oh, we've seen this before. We have sodium, which is a metal, chlorine, which is a gas. Remember, a poisonous gas has a light green color. And when they react together, and you got to put a little bit of energy in. If you remember from that video that we saw, the guy was heating up the sodium. Actually, he melted that sodium and then he put it into the container with the chlorine gas, and this solid precipitate, which was white, started to form, and that was sodium chloride, table salt. Pretty cool stuff. All right, let's put our elements here in the table, and let's count up the number of sodium on the reactant side. So we've got 1 of those, Chlorines are 2. Now let's go to the product side. Sodiums are 1. Chlorines are 1. So we're not balanced. So let's take these numbers and put them over here because we're going to be changing them. I'd like to get rid of those arrows. And let's start balancing. So what I see is I see an imbalance with the chlorines. So the sodiums for now are balanced. So let's take a look. I need another chlorine on the product side. So here are the chlorines on the product side. I cannot separate them out from sodium. So if I turn this into 2, I will get 2 chlorines. So let's change chlorines to 2. But unfortunately, we also have to change the sodiums, but that's okay. Whoops, what did I do here? I think I'm a little tired. So now we're still not balanced, but we're not balanced as far as sodiums are concerned. So where are we not balanced? Here on the reactant side, we need to go over there to the reactant side and place a 2 here. And then that allows us to now fully balance this equation. That makes everybody happy, makes me happy. And that's how we balance chemical equations. So when you're ready to take your quiz, what you do is you send me an email. I will send you the quiz, but you need to be ready to take the quiz. You'll get about 15 minutes to take the quiz and then send it back to me. So don't email me until you have a little bit of time and you want to get this done with. Okay? So I'll talk to you soon.